Schmath. Orange.
Alright, so lesson 61. Chemical mixture problems type B, and B does not stand for Breaking Bad. Just so you know. Now, the type A stuff was pretty straightforward. We had a couple of variables. We called them Pn and Dn. Nothing special about those. What were your names again? Patricia and Diana.
Diana.
Or if you talk to Mr. Saxon, it's poured in and dumped in.
Yeah.
But the way we worked these is we had a volume equation and we had a concentration equation. The volume equation was we don't know how much plus we don't know how much equals some given amount. And remember the idea was, I get the trash can in here. So if you had two containers, I'm actually going to do this because I really like my coffee. Let's call this Pn and Dn, and we're pouring some of this in here, we're dumping some of this into here, and we need to end up with a bucket of basically a specific amount. So we need to find out what are the two amounts that we are combining to make the total. And then once we had this, what was our next step?
Get the percent.
Yep.
That's what I was gonna say.
Copy down the exact same equation, leaving some space to put in the percentages. And you say, okay, one of the buckets we start with has this percent concentration, the other stuff has this percent concentration, and our ending total
20.
has that percent concentration. So this was the basic structure of the chemical mixture problems that we've done in the past. And we're going to do practically exactly the same thing. We still need to have a volume equation, that's a V, a volume equation, and a percent concentration equation. It's still going to be a certain amount plus a certain amount, equals plus, I think, equals a certain amount. Except, whereas before we were given the amount we need to end up with, now we're going to be given one of the starting amounts. Example 61.1. Start down here. 61.1. How much water must be evaporated? Hang on, let's do. Let's change the order here for a second. Let's do 61.2 first.
Yeah, 2's better.
Totally. When Frank and Mark finished milking,
Right.
they found that they had 900 pounds of milk that was 2% butterfat.
What were they milking?
Probably cows. If it was something else, I don't want to know. How much butterfat did they have to add to raise the butterfat content to 8%? So they probably gave us a starting amount. It said that we have 900 pounds, and it says how much butterfat we need to add to get. Did it tell us how much we need to end up with? It said we started with 900 pounds. Did it say how many pounds we need to end up with?
Guys, we're filming.
That's going to be an annoying spot in the video to watch. So example 61.2. Does the problem, it tells us how many pounds we started with, and we're adding some unknown amount. Is it telling us how much we're ending?
No.
No. All right, well, we're going to need some variables here. If we got 900 pounds, and we're adding
Cheese.
Butterfat. We need a variable here. How about B?
BF.
BF?
Like best friend.
Ooh, there we go.
Wait, what?
Or boyfriend.
Oh.
Now, here, if we're starting with 900 and we're going to add an unknown amount, we'll call it BF.
Yeah.
How much are we ending up with?
The total.
Yes, the total.
Yes.
Now, here's what one of my classes a long time ago decided to call the duh equation. Watch carefully. 900 plus BF equals 900 plus BF.
Oh, I said that.
Duh.
Did I lose any of you?
No.
900 plus BF equals 900 plus BF.
That does.
Couldn't
it be-
That would be multiplying.
couldn't
If you
it
say
be-
900 BF, that's multiplying 900
Couldn't
BF.
it be BF plus
The
900?
reason I make a point to do this is we have a certain starting amount, we are adding an amount, and we are ending with an amount. By phrasing it this way, we have three quantities again. Just like we did before, we have a certain amount plus a certain amount, and we're ending with a certain amount.
But what do you do from there, though?
But here's the reason for doing this. By saying 900 plus BF, I am not introducing another variable. I could use this. I could use the same variable.
That's nice.
All right. So this is our volume equation. In this example, it was measured in pounds. Now we need, just like before, now we need a concentration equation. And just like before, we're going to copy down all three volumes. That's BF equals 900 plus BF with parentheses.
What's the
And so
percent?
each of these three volumes has a concentration.
Oh, I get it.
Now, there's some parentheses here just to make it clear when we multiply. Now, whole milk, by the way, is a mixture of skim milk and butterfat. So we're talking about the percent concentration. It's percent, we're talking about percent butterfat in this problem. Butterfat, okay.
Okay.
All right. When Frank and Mark finished milking, they found they had 900 pounds of milk that was 2% butterfat. So the butterfat percent concentration is 2. Now I'm going to skip to the end here. All right, they want to raise the butterfat content to 8%.
Why?
So they want to end up with 8%.
So 8 times 900.
Now, how much butterfat do they have to add? Now listen very carefully. What is it that we're adding?
Butterfat.
Butterfat.
Okay.
What percent concentration of butterfat is the butterfat? Or to put it another way, of this butterfat, how much of this butterfat is butterfat?
Butterfat.
Oh, of the butterfat?
100%.
Exactly. All of it. It's pure butterfat, which sounds really gross, but that's what it is. Well, there we go. So we have pure butterfat, which means that what percentage of it is butterfat?
I'm healthy. 100%.
100%. This is how a lot of these problems are going to have either 100% or 0% in this spot. Just so you know.
So it's not going to give us a percent, we're just going to have to figure it out from the problem.
Exactly. It's, if you read the problem carefully, it ends up being another duh thing.
Okay.
But you have to read the problem carefully. So once you know it, it's duh. But when you're reading the problem, you have to read carefully to make sure you actually read it correctly.
Bless you.
Bless you.
You're so blessed.
So what we have here now is we have this equation here. How many variables are in this equation?
Like 2, 1,
100.
One.
1. BF. Boyfriends.
Beatrice Patrick.
Just the BF.
Beatrice, Frederick.
So on these types of problems, by the way, just so I complete this here. Always start with the volume. It doesn't matter which kind. Always start with the volume, then copy the volume equation, put in the percentages. In these types of equations, when you're given a starting amount, as opposed to an ending amount, when you're given the starting amount, you can use the duh equation, as we like to call it. And when you use the duh equation, there's only one variable. On your second step here, when you put in the concentrations, you have one equation with one unknown. So